Area of segment is a little minor topic in CSEC maths class that is not so popular, but it can arise. Let us have a little discussion about it. First, we are going to draw a circle. So let's go to insert, I think, yes. Let's go to draw, new, and like a circle shape. Shapes on the circle. We want a circle. Yeah, we're using Google Docs, so right, we've got a circle right there. Now, let's identify the center. Center should be right there. Now, let's draw a line from the center. Okay, I can use here. I want to draw another line. Okay, let's delete that line, right? This line there. Put it there. Okay. So I can copy and paste it. No, sorry about that. Right. Copy and paste. No, that's not what we want. Really, this. I'll have to draw another line. Right. And we need to draw another line. Now, before I draw that other line, I just want to point out that this shape there is called a sector. Okay, so that shape here, that the whole major diagram is called a circle. And this shape here that looks like the slice of a pie is called a sector. Now, if you, and these are two radii from center to edge radii. So if you draw a line, which is a chord is a line that touches the edges of a circle, but does not pass through the center, but it touches both edges, it's called a chord. What happened? What was created now? You have divided the sector into two shapes. One is called an isosceles triangle. An isosceles triangle because two sides are equal. It is formed by two radii. So this is an isosceles triangle, and this shape that looks like the top of a cone is called a segment. Okay, so that area there is called a segment. Now, the area of the sector, when you look, let's look at the list of the formulas for us to know what is the area of the sector. Okay, and the area of a triangle. Here, this is an isosceles triangle. What I want is another shape, a curve. Can I get a curve? Okay, what I have is straight line, but here now, can I put it a text? Here is theta. Okay, the angle right here is theta. I could type theta. Okay, this angle inside here is called theta. I'm looking for the symbol theta, but I'm finding it. So let us just use the word theta in the meantime. So this angle there is theta. Okay, so let's go to the list of formulas. So the area of a sector is theta over 360 times pi r squared. Where theta now is the angle of the sector measured in degrees. And the area of a triangle now, there are three formulas for the area of a triangle. Half base times height, if you have the vertical height, yes. Half AB sine theta. That means if you don't have the vertical height, but you have two lines, two sides, you know, the two sides and you know the angle between, it will be half times the product of those two sides times sine of the angle between those two sides. So we can use this formula for the area of the triangle. And then this now will give us, the difference will give us the area of the segment. Let's go back to the shape. So the area of the sector, of the segment, will be the area of the segment, of the sector, sorry, which is theta over 360 times pi r squared. Pi r squared is the area of the circle. The sector is a fraction of the circle. So it's theta over 360, that's a fraction, times pi r squared. That will give us the area of the sector minus the area of the triangle, which will be smaller. And that will be half AB. AB now would be the side, the length of the two radii. So it will be half r squared, because r times r is r squared. Half r squared times sine of theta, and that will, this difference will give us the area of the segment. So let's continue now. The area of the segment, which is this shape that is shaded, briefly shaded here, is the area of the sector, which is shaped like this slice of pizza. And the area of the sector, we said, is theta over 360. Theta is a Greek symbol over 360. 360 is the total angle of a triangle, of a circle, sorry, times the area of a triangle, of a circle. The area of a circle now, because remember the sector is a fraction of the circle. So the fraction of that angle theta out of the 360. So theta over 360 times pi, look, pi there is another Greek symbol, times r squared. R is the radius of the circle from center to edge, minus the area of the triangle. The area of the triangle now is an isosceles triangle. So using the formula for area of triangle, I have AB sine C, where AB are two sides, and C now is angle between those two sides. Now our two sides now is the radius. Okay, so it's a half times R times R. R times R is R squared. Okay, times sine of the angle C. The angle C happens to be theta again, because the angle C is the angle between the two radii. So the area of the segment is theta over 360 times pi r squared minus half of r squared times sine of theta.